sure it's running. Yes, okay. Okay, so I remember from last time what we had learned going through arrays. Remember what the arrays were? And we stepped through all our different pieces of code going on. So we've got the array 4, that was computing the sum of all the different elements of the array. That will be handy to do for lab, because once again we're taking those grades and we're going to create an average off of them. Before you average, you need a total. So there should be some good sample code to see what it's using. And it's going to use the column headers and everything like you need to do for your lab. The student poll program, remember that's the one that was parsing through and okay, we had 1 of these, 2 of these, 3 of these answers by the time it got through to see how many of each type there were. The rolling a 6-sided die 6,000 times. Remember that was doing about the same thing, calculating it up, but using some random number generators in there. Remember, a random number generator is our friend. It's great for if you start getting into wanting to make some gaming things. You don't want to always have the same boring game. So you want some good random generation. And that's what he'll give you. And then the array 7 example was the histogram, where it started doing the asterisks, depending on how many the number was off that part. So that brings us today to start our next steps of this. Character arrays, also better known as strings. C does not really have a knowledge of string. That's something that gets added later. But so their level is a character, C-H-A-R, char, and once again you put the name of whatever you want to call it. Since they know what it's called in C++ and other things, they're using the name string. So that's a good. And then you have to say how long of a string you want to have. If it's going to hold somebody's name, well, how long is their name? We may not know yet. So what do? Worst case scenario. Is it just the first name? Is it just the last name? Is it first name and last name? No. So let's go first name, last, let's give them 25. So what happens when they say this? What does the computer go out and do when it hits this command? It goes out and grabs a spot in memory. It's going to refer to that spot as string 1. And it grabs 25 character size blocks of data, consecutive. It doesn't grab 3 over here and 2 over here and 15 over here. So one chunk it sets up for 25 characters. In this case, a character is 1 byte. So in this case, there's 25 bytes. Now, if we do the same thing with an integer, 25, what do we get? An integer takes 4 bytes of memory. So if it sets up 25 of those, it's got 100 bytes of memory it sets up, or none. Characters are smaller, so 25 of those, it doesn't take as much memory. That's something the computer figures out all by itself. You don't have to figure out what those memory locations are. But if string 1 was a name, we put something into it. So I put my name. Okay. In this case, whatever's there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I just used 12 of those. So in this case, I'm going to come back over here and say, hey, we'll use a string of size 13. So that accurately represents what I have here. My name fits in, including a space in here. Remember, space doesn't mean it's not used. He has an ASCII value of the space character. So that's a 32. Yes, it counts the space. Just remember, each one of these has a value in that ASCII chart for a character, and a space is a character. So he gets a value. And then at the end, actually, there's a value goes into this one because it's at the end of the string, and we'll learn that later. It actually says it right there. Next thing we're hitting, null character /0 terminates it. So that way it knows when we go to reference this, print me out this string. Oh, there it is. Return it back. Even if we had only had, so give us another one here, and we just said Fred, the last one would be /0, the null character. So when we accessed and used Fred, we go down here and he would stop it there. And he will ignore anything else here. What happens on this guy if I try to make him go one further? I try to put a name in larger than what I have. If I don't check first and just stick him in, there's no room for this end character in here. So my name is Morrison. He still goes in, actually. That's the end of our protected zone. This leaked out into other memory. So once again, we could be damaging something else running or just wiped out some other variable by overflowing our array. So that's what you look for worst case scenario. In the future, there'll be things to protect against that. Now, once again, some other languages will keep you, hey, you said 25. You just tried this, can't do it. Okay. Once again, see, they're the all-powerful creator as the programmer. Do what you want. We'll let you. All right. There they are saying that string 1 is 6 elements, F-I-R-S-T. It's 5 plus the end character, the null character that terminates string. Now, even if you're using this as a full name, Danny Morris, that's what our string has in it, the character array. You can still access individual characters. I'm going to go ahead and grab, you can actually do a thing and search for the space and then pull out the next character. Do a little loop that way. Have them enter their name. You can go figure out what their initials are by stepping through. Okay, the first initial here, go. Okay, there's a space. The next one, okay. Grab that one and keep going until we find another space or the end character. Neat little nifty things you can do accessing each of them individually. Because that's what for those who weren't here last Tuesday, while we got the definition of the array here, saying character string, size 13, that sets up the memory to access a particular element of it with that name, in this case string 1, with the square brackets, and which guy you want to look for. Now, what does he start with? We're looking for 1, 2, 3, 4, 5, 6, 7. I want the 7th guy right here. What did I put in here? 6, yeah, wrong direction. You need to do something with 1. Okay, take off 1 because it's going to, this one starts with 0 as our index of the first one. And it'd go down through index 24 in this case. Let me get us back to what it really should be. So, with that, if we want this guy, he would be number 6. See, the array name is the address of the name. So string 1, he doesn't have a value of himself. If we want to print string 1, it would not print Danny Morris. Not if we reference them with like a %D, whatever, because string 1 in this case is the memory address of that first element. So if he is at address 4700, where he started in memory, that's what you would get print out. That's why when we do a printf on him, you use the let me wipe this guy out. %S reference. Because that's a special one that is going to go, and then he looks at him, okay, it's a memory address, and he dereferences that memory address. That's what you call it when you go access what is in the memory address, dereferencing. So that will kick back out what he points to. Notice on the scanf statement, it's a little bit different than we normally see. What do you see different on the scanf statement this time?
There's no ampersand.
Exactly. Why is that? Because scanf. What's that?
Because it's stored in multiple memory spaces?
Well, not quite. Remember, when scanf normally operates, it is copying something into the memory address of that variable. If we said scanf %C &CH. And CH was a char. Remember, out here in memory somewhere is the variable CH, and we put into it whatever we want. The scanf normally would come in, and he's not hitting this. He needs to know the address of CH so that he knows where to put that data. And so while we normally are referring to CH everywhere else, no, we need the memory here so that scanf can do its job. Printf pulls it straight, so we don't have to do any memory referencing. But actually, scanf has to know it so you can put it in. Well, when you're dealing with a string, or actually any array, whether it's a string or your set of grades you're reading in, whatever, dealing with that array, that variable I'll just call it str this time, he's already an address that is stored in him. So, we don't have to say the address of the address. It already is an address. So with a %S, leave off that guy, and go straight to your string. It's supposed to be an arc. All right. Is that making sense, or is that just totally confusing you? Great silence. So hopefully it's sinking in. So, normal
So that
variables,
percent is looking for the array, basically, and then the array tells it which address to go into.
yeah, well, that's, the array variable is actually storing the address. It is the address of the start of the array. Yeah. All right. And the way that the scanf does here, when you're pulling in a string, say if you have a lot of words in a file and you say go scanf this, he reads until there's white space. Or it's just a normal space, considered white space. Can be multiple spaces in a row. We've got a word, 15 spaces, another word. He reads the word. The next scanf statement skips the white space, goes for the next word. But you might want to use that little space before, so it dumps those. Sometimes it's good, sometimes not. So be careful not to write past the end of the array, because once again, it's going to corrupt whatever comes after it. All right. There's the big warning of what would happen. If you scanf something, scan in a name or something from the keyboard, it's bigger than the array, then you got to corrupt stuff afterwards. Now, passing arrays. What does that mean? Remember our functions? We got our functions going. Since we've already done functions, we can talk about this part. All right. So we had a function down here. We're going to need he does his little stuff that he needs to do. So up here's our main. And somewhere he's going to call ABG equals average. And you've got count. Semicolons. Okay, now we got average, we're going to pass him count. And grades. Now let's see, that's what we need to find out. To pass an array argument to a function, specify the name of the array without any brackets. Right there, that first line. Because we've got our array, in this case grades of 10. That's what we're doing in our lab.
So what that does is initialize the array and sets aside the memory spaces.
Yeah, actually, what happens here, normally when you're calling a function,
Well, not there, I was talking about up there, when you do the
yeah,
if my array 24, that is initializing the array and setting aside the
yeah,
memory spaces.
that was good. That's in the main. And then this is
My
from
function,
main, you're
yes.
calling
Calling the
the
function,
function.
and then telling it what you input.
Yeah. That's right here we're calling average, passing it count and grades. So here's the actual function where it's going to do the work. So it's okay, count and our grades. That's what we're going to refer to it internally as. We can actually say this as in and stuff, just to make sure that you understand this can be different. When you call average, you're passing at count, you're passing at grades. Inside, he's going to refer to the count as n. So if he has a for loop, like for n equals 0, no. Let's say x equals 0. Okay, x equals 0, x less than or equal to n. No, just less than n. Remember what's going to happen there. X plus plus, and we do our total plus equals stuff sub x. Then return total divided by count. Yeah, we call it there. There, that's what it would do to average. We already had this array that's got how many other things in it. See, up here we said 10. So we're going to do 10. So we pass it down to him. He doesn't care how many there are. We're going to tell him here. So if this time we have 10, okay, he'll process 10. If we have a different set later that we want to average, a totally different set of guys that's got 150 in it. When you call him, he'll do him with 150.
So, given the example that we had in the lab today, would it be recommended to do multiple for statements, I guess, for less than 10, less than, but greater than 10, or greater than 9 but less than 19, and divide it like that? To where you're running...
No, we're going to get into what you need to do for the lab here in a little bit. So, keep in mind, we'll get there. But as we're passing this in, count. When we pass count over, it's actually making a copy of that variable. So the count is set up out here in memory somewhere. So when main does that, and when he calls average, average creates a new copy over here that he's going to call in. If this was 15, he makes a copy of 15. Grades, however, it's not going to make a copy of. Because grades is the address. Remember. Because he's that array. He's different than a normal variable. He's an address. So when you pass grades over, and we pick up stuff, okay, stuff is here. He's referring to the same place that grades is. We can call him something different, but he's the same thing. Now, fun part is, if you're over here with count, and you pass count over here, if I did something in here and changed in, so I use him to come in, he gets that same value. But if I start playing with him and add him and subtract him, divide him up, if I change him, he doesn't affect the original. Now, if I do something to pass that value back and say, do something, then we can do something with whatever he was, it goes back. In this case, I'm putting him into ABG. Gets that value. It goes back. I could have said count equals average of count, whatever. That doesn't make much sense, but you can do it for whatever purpose you need. And in that case, upon return, it assigns that value in. But since we're passing that memory location, you are dealing with the real stuff here. If I start moving these things around or wiping them out, I'm doing it in the main set of them. Now, if we did not do that, now if for some reason you need to make a copy here and play with it, but you don't want to mess up your original. You want to, before coming down, create a new array, copy the elements with a little for statement, a while loop, something, a for would work best. Copy it over, then pass that one in. So he could play with it without messing up your original. And that is because we're passing, we would say by reference rather than by value. Here you pass the value over and they play with it. Here we pass the reference to the original. So they're actually messing with the same stuff.
So if you do something like int grades 1, and then do your brackets for 10, allocate them to the memory addresses, and then equate that to their original grades.
I'm not quite getting it at the moment. No, it's in your head, right? It's just transferring to mine at the moment because I was thinking of other things. We can figure it out later. All right. So y'all get that? The difference between call by value and a call by reference? Yeah, they even use the terms here. Call by reference and call by value. Value is just the value coming over. Reference is the memory address, so you're dealing with the same stuff. Yeah, that's where you could do some different things with it. Ooh, I didn't touch it. There we go. And the prototype. Remember, before we do this, we create the prototype ahead of it. I just skipped that step because I don't want to waste time with it right now. You set up the prototype first. So you can say in the prototype, remember you don't have to put the variable names you're going to be using in the prototype, as long as it knows the data type you're going to use. But you'd have to say int and use the square brackets empty. Because okay, we're going to be sending in an array of integers, so it knows what kind of memory location is set up. And the array size, what's int. So modify array, what it's got up there right now, it's going to be written. Give me a spot back here. I need a quick erase button. Clear screen. Modify. I'm trying to look at the screen. Modify. Array. In array, comma, int. Once again, that's for the prototype, because when you actually define your function, is when you would say, we're going to call him B, we're going to call him int array size. Whatever. Doing things in parallel arrays. What's going to happen, what they're going to talk about in this one. Okay, you had a student's grades and you needed something else to go along with it. Or let's see what they're using here. Student IDs and student GPAs. How's that sound? If you needed to track both their ID and their GPA, but it's for the same person. So that's going to be our fun part. You got to keep those arrays parallel to each other. So if we had int ID, and we're going to set this up where our class can hold 40 students. Int GPA, same 40 students. So then that way, we're just going to set up our memory. With ID and GPA. And then in our for loop, as we're doing stuff, I say 40, I've got hard coded at the moment. You know, normally you wouldn't really hard code that. What could you do? Do a pound define up there for your size?
X is less than ID.
Hmm?
While X is less than ID.
Well, less than the value,
Yeah.
the number there. So if I did a pound define nums students 40, now I could use in here num students and there students, yeah, there you go. That'd be the better way of doing it. So then once again, now we're going to have 70 students. We just change it to this one spot. Everyone gets it, and he just sets up more memory each time. So what we're doing stuff in here, and now we can do things with ID sub X equals whatever, GPA sub X equals whatever. So we're going to be dealing with the same student, the same ID. We've got their data are all here. So whatever we want to track on a student, their address, what city they're from, what their major is. We just have different arrays, still numbered the same thing, such that if they're number 5 in the list here, number 5 is your information here, and here, and here, and here, and here. Starts to build up more data. So much of what computing is, it's manipulating data. So gathering data, manipulating it, getting, gleaning information from the data, what averages, things like that. If you have a good program, I think some of those people who do all this global warming stuff didn't have very good programmers with their computer models. They're ignoring the wrong data, so making up other data, you know, these different things. But you want to track data, deal with data, even in gaming, tons of data, and you want to keep up with it all. We'll find later on there's easier ways to do this, but this is the start of it.
That's not needed, right?
So when you're
Scan it, line 15.
line 15, it's got a blue on it. It says a scan of %D, %LF. In this case, it's ampersand ID sub I, ampersand GPA sub I. You do need the ampersand there because you're referencing an individual guy of it. Because they're scanning it and sticking it straight in.
So what's the
You could scan it into a temporary variable, then assign it into that guy. Yeah, that's the thing about you're populating individual components. You're going to need to dereference it that way. Okay, multiple restricted arrays, yes. Here we go. This gets into part 2 of the lab for those bonus points. Or keep that for now. Essentially, you got to do what we call multi-dimension arrays. The best thing with this is you're going to think rows and columns. Remember we had our nested for statements? For I equals 0, whatever, then within that is a for j equals 0, j less than 3, j plus plus. So we're doing as within j's. Same kind of thing we're going to get into with the array. Of course, to store data like we're dealing with this. trying to remember what example I had thought up for dealing with that. Doesn't come to mind at the moment. Oh, why don't we look at where somebody sits in the room? Let's just take this half over here. How many spots we have available? There's 4 chairs by 4 rows. If we wanted to store whether a person was in that chair or not, we could say, okay, let's do seats. There are 4 this way and 4 that way. Actually, we're getting rows, columns. So, row 1, row 2, row 3, row 4, seat 1, seat 2, seat 3, seat 4. So that would be a column. So now, you can initialize it and say who's in what seat. And you do that by squiggly brackets again. Now, we just had a single array. I think we covered this last time. We just wanted okay, grades. We'll use our grades guy since we've been using him for stuff. We come in here and actually list the individual grades. On out. And that squiggly bracket. And he pre-populates those values with these guys. If you don't give enough of them, I just stop at 23. It puts the first 4 as this, and then he will initialize the rest to 0. That is a nice thing about that. If you start to initialize it, but don't give everything, he assumes 0 and does the rest. If you don't do anything, he doesn't initialize any of the guys. And they have whatever leftover memory happened to be in it. If you want them all 0, just put 1 0. They all get 0. Maybe you put more out here than you've got listed. He does flag an error, and he'll crash on you. He will not compile. All right, so you understand all the different options on that? You'll probably go through those a few more times. They're in the notes from last time. So if they're in the notes, possibility you will see them again in the future on a nice little exercise. All right. But when we're doing this multiple dimension arrays, a few different options on how to do that as well. Then we'll see which one makes the most sense to you. Whichever one makes the most sense, use it. All right, so we've got 4 by 4. We open up, we come with a second bracket within, and you list for the first one. So we're saying for the first row, column number 1, column number 2, column number 3, column number 4. 1, 1, 0, 0. There's a comma between. Then I could come in with the next one, row 2, 1, 1, 0, 1. Now this can stretch all the way out, or you can just format it nice and pretty, however you see it. So you can deal with it easily. And then 1, 0, 0, 0, 1. Oh, wait. Yeah. And then on the end, 0, 0, 0, 0, and then a final terminator. And that would initialize all of them. Another way you could do it is just say equals, and put them all out there. 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0. On one big, huge long thing. You just have to remember, like, okay, it's gonna take it, it's gonna break after 4, and it'll break after 4, and it'll break after 4. Which one is more readable? Yeah, this method here will make more sense in your mind once again after you slept overnight. You worked on this until 3 o'clock in the morning and got 2 hours of sleep, got up the next morning, and what in the world was I thinking? This will remind you a lot better.
That's hard coding.
That's it?
So that's hard coding.
Yeah. That's if you are pre-initializing to something.
I want some hard coding.
Yeah. So there might be a reason you want to do it that way.
Sure.
Let's say, but if it's going to be something you're dealing with to actually make a usable program, maybe not. But once again, it depends on what that is. If those were flagged variables for initializing a certain program, then we're going to have these functions available unless they go and change them. Okay, turn on this kind of thing, turn on that, turn off that. Okay. They start getting a little freaky here. Another thing you can do, if I wanted to come in and I said, okay, we're going to say 1, 0, 1, 0, 1, and end it. That doesn't quite match what we've got over here, does it? Well, what he would set them up as actually is 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. Anything that's not specified would be initialized to 0. So, now do you think that's a good idea? If you're going to start doing it, just go ahead and do it the regular way. So, once again, that's going to make the most sense right here, doing it this way. All right. I'm going to keep them up there. And then, once again, to reference certain ones. All right, let's see. Make a little grid here. Rows, columns, so row 1, 2, 3. Actually 0, 1, 2, 3, that's our rows. Our columns are 0, 1, 2, 3. So we wanted to access this guy right there. Who is that? Yep, that would be seat. Row first, and column. I guess him. So you can do the printf, %d, seat sub 2 sub 1, or x, y, if you're calling him x and him y, row, column. So you can put the variables in here, step through.
So when it inputs the data, is it going to put it in?
It depends on which way you step through.
Columns?
It depends on which way you step through. For lab, let's say grades for students. And we're going to do students. Students of X, good one for, because index. So knowing which student we are, and then which grade. And so I can read in, okay, for X equals 0 to x less than our num students. Of course, in our lab we've got 10, so that's something you can define at first. X plus plus. Whoop, now we come into 4. G equals 0, so that's a grade number. G less than num, num S and num G. They could be different, and I'm thinking they're not. G plus plus. All right, now we can scanf. Let's say our file, read in the grade, and we could put that straight into the address of student sub X sub G. Since we are accessing individual element of the array, we would use the ampersand. So he would scan in from the file, whatever's on that line, stick it in here. Now, normally I said we would only have our squiggly brackets to make things more readable. Since we're only doing one thing, you could get away with just one, and without any, but this is more readable. So, all right, so it reads these in. X starts off as 0. G starts off as 0, so here we are. He reads a grade. And then he does the next G. We go all the way through all the G's. Then we come back up here. X increases. G's reset to 0, so we're here. And we're going to fill in those grades. X increases. G is at 0 again. And we do all these grades. See how that works? You think of things in a two-dimensional grid, and that's the way we're doing our data. In actuality, the way the memory is going is like X is 0, G 0, 1, 2, 3, X is 1, G is 0, 1, 2, 3. X is 2, G is 0, 1, 2, 3. So it's going to, the data in contiguous memory does this. Right down the row. But you don't have to know that. Because you're doing it this way, think of it as the grid. The computer's got to take care of the other part. And now the fun thing is, it doesn't stop there. You want to get here, now you can add another dimension to it. X, Y, Z planes, you know, so points in space. You want to start graphing out where galaxies are in the stellar map. Well, give it stellar coordinates. You can find that, you know. Use the stellar coordinates as your indexes and mark where things are there. See, different ways you can use these. All right, here's another way. If you, they're pointing this out for some silly reason here. You can reference a double scripted array. That's like a 4. You can do it as one set of seats. So 4, 4, like that. Let's see, reference a double scripted array elements. C interprets that as, okay, they just, okay, they're pointing out an error that people do. You cannot do it this way. That's what they're saying. Good, because I never did it this way. But if you do try it, it's going to take that just as, what it's showing there, it takes that second one, and so now it's saying,
Four groups of four, you're gonna have
yeah, we're,
16.
yeah, and it freaks them out. So what you're expecting it to get somewhere down here, you actually wind up getting him instead. So make sure to keep it separate sets of brackets to reference it. That's one of those things that the compiler probably will not find as an error. It'll say, yeah, sure, if you say so. And then when you run it, you're going to be pulling your hair out because it's not working properly.
It's gonna take the last variable that's entered in, not
Yeah,
first.
that's what they're saying it does. I hadn't tried it myself, so
So, like our example over there where we got 4 by 4, we have, in memory, you can access it directly saying 1, 2, 2, 0, whatever.
yeah.
If you did it like that, it would do 16 memory spaces, all consecutive, so you had to go C sub 15
Yeah.
to get, what, 3?
Well, one of the things he might do there too, gotta watch out. I think one of the things, I'm not sure if it's in that case or not, since he's expecting it to be this kind of format, it may actually wind up returning a memory address of something down here. So that might be you get a really strange number you're not looking for. Okay, yeah, this is kind of like what I just showed over here. The column addresses and the rows, get the row at the column. Remember, rows always come before columns. Now, which is kind of funny, if we set up coordinates, normally if you're dealing with something, your x is always this way and your y is always this way, and you always do like x comma y. This is reverse of that. Rows and columns is the reverse of x, y, because your rows are your y and your columns are your x.
That's not
Okay,
referred to as X and Y.
Huh?
Yeah, that's not referred to them like that.
Yeah. Go with I and J if you need to. I as index, and then J is the subcolumn. That way it won't confuse you. But however, if you call it X, if you call this X and you call this Y, then now X is your rows and Y is your columns. It's just the reverse of what you would normally think because of all your years in geometry or whatever, algebra, doing your things. You can even do games with this. Having a 3 by 3 array and storing something in it. Store either an X or a 0 or a blank, and that way you can know what's still available or what's not. Storing in your guy. So that's where they even have a thing to come in through here to determine whether there's any spaces available on your board. Let's see how they did this part here. So int row and column, so there's our subscripts for our rows and columns. And then an answer, and they're going to set it to 1. We're going to assume that the board is filled. Let's say go through and look for a blank. We'll leave one there. Alright, so it starts off our 0, and as long as R is less than 3, and then within that it's a 4 of C, starting at 0, as long as C is less than 3. And if tic-tac-toe board sub R sub C equals blank, I'm just going to change answer to 0. Now notice, since there's only one real line of doing something, they left off all the curly brackets. So this is stepping down, okay, that's the only thing. Rise again. personally, I don't like that programming style, because what if we come in the future and add a second line of code? You now have to go back and add all those curly brackets, actually, well, here, under the if curly brackets. Unless you added a statement other than if, then you've got to do curly brackets for this guy, but not this one or this one. And put them all to start with. You can enhance your code any in the future you need to without missing something. So, just to make it fit on one page though right now, it does eat up more space. Okay, so anyway, it's got to go through. R is 0 the first time out. C is 0. He steps through if R sub 0 sub 0. And this time, we're not students and grades anymore. We are R and C. So 0 sub 0. Okay, he's an X. So we don't look at the if statement. And we go to 1, 0 sub 1, 0 sub 2. Okay, now we start over. So he's going to go to 1, he's going to go to 0. Okay, nothing. Well, he's got something. So he's not going to do, he's got some. Here we go. At 1, 2, we've got a space. So R sub tic-tac-toe board sub R sub C equals space. So now we're going to change answer to 0. Goes to 1, we're going to change him to 0. Let's say answer, A-N-S. So there. That's why I type, you know. So now when we return, we return back, we've got some spaces available. So well, in this case, it doesn't matter whether it's plus plus R or R plus plus. You're not doing anything with it at that point other than incrementing it. So remember, plus plus R means increment it, then use it. And the only thing that's happening at that point is incrementing. But if we had answer equals R plus plus or answer equals plus plus R, that makes a difference. I prefer the plus plus afterwards, if you're just doing it plain. That's what they named the language after C, was C++, because they added the C. So, all right, there's where we start thinking of it in a three-dimensional terms. Since we can't really draw that too well on the board over here. This one's tracking, let's see, students, let's see, number of seniors, so it's got what year the person is, freshman, sophomore, junior, senior, which course they're taking, on which campus. So that of our computer science courses were listed here, and we had the Tyler campus, the Palestine campus, and whichever other ones we have based off this way. You can store in there the number of students that are seniors taking, in this case, let's see, that one's at the top, so that is course 0 at the campus number 2. And that gives us that block of data. So you can track a lot of different stuff that way. And here's, where are the, this is playing with those different ways of initializing. So if it says to initialize this array this way, and then it, okay, over here it's going to print out what's in the array. That's all this guy. It's the loop for printing out the stuff like we've already done over here. So we're thinking array 1. Can y'all see what it says array 1 has in it? How they initialized array 1? give us some spots here.
4, 5, 6.
These are some of the crazy questions they like to ask on tests. So if I'm feeling sadistic the night before I make the test, I might throw something like this on there. Because this is the ones, let's screw with your brain in the middle of you trying to think and see what happens. So, array 2 to 3, once again we're going to have 2 things, 2 rows, and 3 columns. Let's go ahead and think of it in that format. So, array 1, we're going to print out, we're going to initialize it, 1, 2, 3, 4, 5, 6. Where does those data go?
1 Jupiter across the top,
Yep.
4, 5, 6 on the bottom.
Right. So that's, once again, it's broken into the individual, this and this. Because we've got 2, we're going to have 2 sets of 3. Best way to look at it, best way to initialize it. Just as we step through to print out, what's in, we say 1, 2, 3, 4, 5, 6. And we went through our rows and columns to print out. The next set, all together, 1, 2, 3, 4, 5, 6. Where's it put them?
1 Jupiter across the top, 4, 5, 0.
Yeah, 4, 5, and remember, there wasn't enough, so he initialized that last one to 0. And so when it prints out, it does 1, 2, 3, 4, 5, 0. Last one.
1, 2, 0, 4, 0, 0.
If he's saying 1, 2, 0, 4, 0, 0. Agree or disagree? Y'all just gonna let him answer everything and trust he's right, huh? You guys see, you gotta look on his paper during the test? No. We're gonna have him sitting right over here. You don't wanna look at his paper anyway. No, just.
All the time.
So, agree or disagree? All agree? Raise hand. All disagree? Good, because I believe he is right. Just make sure, right down here, they show 1, 2, 0, 4, 0, 0 is what it would print. Just like that. Good job.
So you don't
Smart
have,
cookie.
so you don't have to put the data type in the print array?
Okay, in the print array,
You don't have to put the data type if you have a double, it automatically generates a double.
well, up here, wherever it's, okay. We're passing in an integer array.
Oh,
To
there's a
this.
function.
Yeah, this is a function.
Okay.
Yeah, that's the fun part. This has built upon everything, so that's why it took 2 pages to show you the program this time. So up here is our prototype. We're going to be using print array. Passing it an integer. Now, here's a trick they did. So they put this const int here. That constant key tag between means once the print array gets it, it is not going to allow him to change it. If you do something that would change the array during that, it is going to flag you with an error. Because he said, don't touch it other than for reading. They're making it read only when they pass it to the array. By putting
Putting the void
const.
in front?
Huh?
By putting the void in front?
No, by putting const in front of the int
Okay.
in the function call. Well, not in the function call, but in the function prototype, and you'll see it again in the function declaration part here. Since it is a constant, so once again, make it read on. But they're going to say the size coming in, and then here's where it calls it. It calls print array, passing it array 1, which is integer, blah, 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 blah. Print array 2, which array 2 was same thing. The way that he has made up here. It is doing up a fixed size. It will only handle a 2x3 array in here. Because it didn't pass him anything different. If it has to pass something different, it could do it.
How was that the way we do the print after the arrays?
What's that?
You got that way right there, there was another way you got up there just a second ago.
Right, well, where it's actually stepping through, we got the for loop, another for loop within it, and then there's our printout. I and J, so I sub J. Once you get the outer loop, it's going to be your first index. The inner loop is going to be your second index. If you had a third index, you'd have another for loop inside of it. That would be K in this case. Normally, if you're doing that, you're going to keep these to be consecutive layers. X, Y, Z, I, J, K, or if it makes sense on your other variables, student, grade, whatever. All right, now that's actually good for today because there's still quite a few more slides.
That's what I was looking at.
What's that?
So, we don't, if we're gonna print what's in the memory values for the array, we don't have to do the print app and call up the specific. We can just say print array.
No. If you're pulling the elements out, you have to step through each element to pull out the print. If you just say print array, you're going to get the memory address printed. Actually, well, in this case where he says print array, that was the function back here that did all the stepping through and printing each character out. So if you're going to be doing a lot of printing arrays, yeah, go create you a function. And if it's of different sizes, make sure to pass it something where you can say, okay, I want you to print an array of this size. And then when he gets inside, he can do all the work. And you can call that each and every time. And you've got your own function now. There's not a built-in function for doing it. But you can do it yourself. Create the one, we'll take care of it from that point on. Let's see, they've got a different program now, they're going to call that same print array. This time, so they're passing in the array here, student grades that they've initialized, students exams. So here's, for each student, here's his exam grades, another student's exam grades, another student's exam grades. So it's right there in the PowerPoint. Try to set some stuff up for our lab. But, of course, you're going to be populating this from reading a file. All right, like I say, that's where we're going to stop for today. So hopefully, see those who show up for class can get extra bonus on that lab if you're in my lab because you're learning what's going on. Skip class, you know what's going to happen. If you did not get your test back yet, I do have those with me.